Question number 15. A. Figure 9 shows a setup used by a student to investigate how a siphon works. So we have this container or beaker containing water. There is a delivery pipe and we have another container. So Roman number 1, state what would be observed when the student sucks the tube at point A and release it. So what will be observed is that upon sucking, water will flow into the container, this empty container, but upon releasing, then the water will stop because this container is it is higher, it is higher than the container the student wanted to suck. So we can say Roman number 1, upon sucking, the liquid flow flows in the delivery tube but stops on releasing because suck force is withdrawn. Suck force is withdrawn. So that is what will be observed. Roman number 2, explain the observation in 1. So like I have said, the liquid fails to flow on release because there is no pressure difference to push the liquid up the tube without sucking. The level of the container is above the liquid level. So we can say the pressure difference to push the liquid up the tube is not there because the container the container with liquid is lower than the other one. So that is the reason this container need to be at a lower level from where the water is to be delivered, or the source of water, so that the pressure difference will enable the water to flow through the delivery tube. So that's how we answer that question. Let's go to part B of this question. Question number 15B. We are told figure 10 shows a test tube inverted and floating inside a plastic bottle containing some water. The bottle is sealed. So we have the cork sealing. We have the air trapped inside the bottle. We have test tube inverted. We have trapped air inside the test tube. We have water and the bottle. It is observed that when the sides of the bottle are squeezed, the test tube sinks. Explain this observation. So if you squeeze the plastic bottle, you reduce the volume. Volume reduce. reduce, pressure increases. As a result, the pressure that increases forces more water to get into the test tube. Once the water gets into the test tube, it increases the average density of the test tube. So the test tube will sink. So you can answer that by saying upon squeezing, volume reduces, pressure increases, forcing more water into the test tube. This increases the average density. This increases average density. Density of the test tube thus it sinks further. So that is the reason why the test tube sinks as a result of increase in water. Average density reduces, or average density increases, and that is why the test tube sinks, and that's how you answer that question. Number 15, part C. A metallic box weighs 188 newtons and measures 10 centimeter by 30 centimeter by 8 centimeter. Determine the maximum pressure it can exert when lying on one of its sides. So we say pressure is equals to force over area. So if we have more area, then it will mean that there will be less pressure. So here we need to find the minimum area. So if you say that this is our box, a metallic box, like that, and this is 10, this is 30, this is 8. So the side with the minimum area is the one that will exert the maximum pressure, and that is this side, that is 10 by 10. So we can put it like that. We can put it like that. So this is 8 and this is 10. So that's when we have maximum pressure. So this means the force is 188. You divide by area is given, length is the units are centimeter. So we say it in meters, it is 0.1. You divide by 100, you multiply by 0.8. So you use your calculator, you find this is 23,500 Newton per meter, or you can say it is 2.35 newtons per centimeter squared. This is per meter squared. So that is the maximum pressure it can exert on this side of 10 and 8. And if you do that, you'll be able to get 3 marks.